Okay, so one more example, and hopefully you'll start to sort of figure out the patterns here and what's important and what's not. Again, let's make sure that I look at these things as factors and then factor things out. So 8 and 2, so let's try a positive 4 and a negative 2. So that works, which in this case actually means that an x plus 4 here and an x plus 4 can cancel. So I'm going to cancel that right now, and that helps me when I go look for my common denominator, so I don't have too much in there. So this one is an x plus 2 and an x plus 1, so no canceling there, that's a shame. And then here it's an x plus 2 and an x minus 2. That's our very, very common pattern. So that's a little messy, so I'm going to rewrite it this time so that I don't lose track of what I'm supposed to be doing. So there's the first one, because you always leave a 1, right? And I don't get to cancel anything in there yet, so I have to copy all of that. And then x plus 2 and x plus 1. I'm trying to squeeze this in, which is not going to work, so I'll have to either start over or write it here. So I guess I'm writing it here. Okay. So let's see what kind of common denominator I have. So I know I need a bunch of stuff. So I need an x minus 2. I need an x plus 2. I need an x plus 1. And I need an x plus 2, which I have, and an x minus 2, which I have. So those are good. So that's it. So it is, unfortunately, it has 3 factors in the bottom, okay, which is not horrible, because in the bottom, especially in the denominator, you can leave it. It's easy to see when your function be undefined if this was a function. So let's check what I need. So in the first term, I only have the x minus 2, so I'll need an x plus 2 and an x plus 1. So x plus 2 and an x plus 1. And then we get that minus thing again. So minus x plus 5. I have an x plus 2, I have an x plus 1, I need an x minus 2. And when I work with this, I'll have to make sure that this negative goes to every single part there. And in the last one, I have an x plus 2, I have an x minus 2, so I need an x plus 1. So that one's going to be the easier of the versions here. So, okay. I'm going to get more junk. I gotta distribute all this stuff. So x plus 2 times x plus 1. Well, actually, that one's right here. So I can just copy that. Minus. So let's see what I get. I get an x squared minus 2x. But a negative 2x plus 5x is actually going to give me plus 3x. And then 5 times a negative 2 is a negative 10. And then plus 4x plus 4, all divided by x minus 2, x plus 2, x plus 1. Almost. Got to start collecting like terms. So I have some x squareds, but x squared minus x squared is actually going to cancel. So that's good. Then 3x minus 3x is 0, because notice that negative distributes, plus 4x, so I get 4x, so let's cancel that one out too. So I'm sort of keeping track of what I did and did not do yet. 2 minus a negative 10, so actually that's 2 plus 10, that's 12, 12 plus 4 is 16, plus 16, all divided by x minus 2, x plus 2, and an x plus 1. And you could leave this, but since that top is easily factorable, it probably looks better if I wrote this whole expression in factored form. So finish off your problem, copy that long denominator one more time, and then leave it, because it's useful to see where all the zeros will be in the bottom. And in this case, you can even see where the zeros would be in the top. So that's something that usually you'd like to see. So thank you.